Now we're going to take a look at the summation rules listed at the bottom of page 6. So these are also some shortcuts that you might find handy. There are 3 statements here in the box. We are just going to read through them and talk about how to use them, and we'll do some practice in the next example. We are not going to prove these right now. In section 11.5, we are going to learn the principle of mathematical induction, which can be used to prove certain statements in math. And so we will actually prove these guys when we learn mathematical induction in section 11.5. Okay? All right, let's read through the first rule here. So this statement right here, let's just try to see what it's saying. You're summing from I equals 1 to n the quantity I. So if you actually took a minute and wrote out the series here, you're actually adding 1 plus 2 plus 3 plus 4 all the way up to n. So what you're doing here is you are adding the first n natural numbers. Okay, so the first n many counting numbers. Okay, so what you would do, okay, because say you had a whole bunch of these, like 1,000, say you were adding 1 plus 2 plus 3 plus 4 all the way up to 1,000. You certainly don't want to jab all that into the calculator. Okay, this provides a shortcut. All you would do is plug and chug into this formula. Okay, so to add 1 plus 2 plus 3 plus 4 plus all the way up to n, you would just punch in n times n plus 1 over 2. Okay, n is the upper limit of summation. Okay, that's all you would have to do. So let me show you an example. Okay, so let's do it. Let's add up the first 1,000 counting numbers. Okay, in summation notation, this would be the sum from I equals 1 to 1,000, and the expression would just be I. Okay, so again, if you translated that, that's 1 plus 2 plus 3 plus all the way up to 1,000. Okay, use the shortcut. Okay, n is the upper limit of summation, so that's 1,000 here. So plug into the formula. It's going to be 1,000 times 1,000 plus 1 divided by 2. Okay, then I would put this into the calculator. So that's easy enough to enter. So 1,000 times 1,000 plus 1, and then divide by 2. And there's your sum. Okay, that's a pretty cool number. So if we add up the first 1,000 counting numbers, the sum is going to be 500,500. Okay, that's a lot easier than punching in 1 plus 2 plus 3 plus all the way up to 1,000 on your calculator. You'd be there forever. Okay, the other 2 statements are very, very similar. So in the second statement, you are adding the squares of the first n natural numbers. So you're doing 1 squared plus 2 squared plus 3 squared plus all the way up to n squared. So I'll write a description right here. We're adding this time the squares of the first n many natural numbers. Okay, so if you're adding up the squares, you're going to use this formula instead. Again, n is the upper limit of summation. Okay, the last formula here, you are adding the cubes up. So you're doing 1 cubed plus 2 cubed plus 3 cubed all the way up to n cubed. Okay, so I'll again write a description here. We are simply adding the cubes this time of the first n many natural numbers. Okay, so if that's what you were summing up, 1 cubed plus 2 cubed plus 3 cubed all the way up to n cubed, you would plug into this formula, and again, n is the upper limit of summation, okay? In the next example, we are going to do some practice using the summation rules and also the summation properties.